So for this manufacturing process assignment, we're going to be going over how to use a wood molder, specifically the Powermat 700 Eagle molder by Weinig. So this molder specifically is a six-headed molder. It feeds from right to left. Behind each one of those green doors is one of the molder heads. Starts out by hitting first a lower jointer head, two side heads, two top heads, and then a final lower head. We're going to go through the whole process of starting a job from scratch, setting up the machine so that it's able to run, and finally actually running product through the machine. Now, practically every job we do starts with one of these pink pieces of paper, detailing the quantities and what profiles the customer wants. If we don't already have the profile, it'll also come with one of these sheets. It simply details what they want it to look like, as well as the dimensions of the new profile. Alternatively, they could just send us a sample of the product they want us to run. Either way, though, the first step is to make a template of the profile. Sometimes that is done by hand, with me simply sitting down with a set of files and trying to make a profile that matches the sample perfectly. Or if time is not an issue, we will simply send that paper drawing to another service that will cut a template for us. Something to keep in mind while making these templates is I know my steel has to be longer than the actual profile itself, and therefore my template needs to be even longer than the steel. Keeping these things in mind is pretty important. After many long years of experimenting, our shop has kind of come down to using one of two steels, either M3 Plus high-speed steel or this carbon M2 steel combo, which has just got a thin layer of carbide steel attached to a layer of M2. Once we've gotten the right steel selected that's the best for this job, we take it over to our handy-dandy chop saw, give it a quick measurement. It doesn't need to be too accurate at this point. There's quite a bit of wiggle room. And then we give it a quick chop. So once that piece of steel has cooled down, we take it over here to our industrial disc sander, and we need to start squaring off the edges, as well as giving them a nice smooth finish so they sit squarely inside the head they will eventually go in. Because I'm not actually just making one knife, I'm going to be making a pair of knives. They need to be almost identically balanced and have the exact same weight. So we take them, and here's a previously made set of knives, and I get the weight for them, and they need to be within 0.05 grams of each other. You can see that this set of knives is exactly 0.05 grams apart. So that's the tolerance that our machine can handle to not have vibrations that could possibly damage the bearings in the machine. This is one of our 4-inch heads that you're seeing now. We also have 2-inch, 6-inch, and 9-inch heads for different size knives for different size jobs. Once the knives are mounted in the heads then get mounted into the molder and do the actual cutting of the wood themselves. They all spin at a maximum of 8,000 RPM. After getting our knives mounted in our head, the next step is to take them to our grinder. Whether it's a new profile and I'm grinding the knife from scratch, or it's an old profile and I'm sharpening the knives before I run it, this is the next step in the process. What steel we're using affects what grinding wheel we actually use. In this case, I'm grinding a bit of carbide, so I'm using a diamond flecked wheel, but we also have a borzon wheel that we use for high-speed steel. Can't use the diamond on the high-speed steel because the diamond wheel is actually more porous and it picks up impurities from the high-speed steel. The machine actually works by having what's called a stylus follow along with whatever profile is in to match the knives. Stylus being, in this case, that small round ball bearing. The stylus is actually interchangeable depending on what profile and what job I need, as well as the profile itself is obviously interchangeable as well. As you can see, now with this new stylus in, it follows along on these more complex patterns, which makes the entire carriage that's holding the head and the knives in it follow along the same pattern. That way the knives are ground to the exact shape of this red pattern. So once the knives are ground, we take the head with the knives in it out of the grinder and take it over here to the OMA system, which clearly stands for the Optisches Mess- und Anzeigensystem, or more commonly, just the optical reader. The optical reader works by projecting a light up through this periscope, which has a 20 power magnification. The light then casts a shadow against the knives, which are on the arbor down below, and this allows us to take very accurate measurements of the knives in relation to how they will be placed within the molder. Once we make the proper transverse and axial adjustments to get the knives exactly where I want them within the optical reader's periscope, we then take a measurement off of the dial down below. So for example, this is read as 2.672 inches because we're just 2 hash marks past the 7 line. So now that we have the measurement of the knife's diameter, we can hop over to the computer part of the molder and plug that measurement in for that knife, and the computer will auto-populate that throughout the entire system. This is useful because once the machine, the molder, knows all those heights for every single head, it can auto-adjust itself to the correct width and height by adjusting the side head as well as both top heads. The height and width are based off whatever I set them to on this screen. So here you can see that the height is just below 3/8, the width just below 1 1/4. I can also set the wheel height as well as the feed rate from this screen. So once all that's set in the computer, then it's time to go about actually putting on the heads we need for this job. Well, technically I can change all 6 heads to custom knives. At most, I'm usually changing 4, and on average, I'm usually only changing 1, sometimes 2, as most wood profiles have either flat sides or a flat bottom. Therefore, I can keep flat or straight knives in those heads almost permanently. In fact, 2 of the heads pretty much are permanent. Those would be the first top head as well as the first jointer head. The jointer head door was in fact stuck. I couldn't even get it off to show you a better picture. Now these 2 heads have a different style of head because they are primarily used to hog off large amounts of material. So they need something that is more designed to that purpose and less custom. So here you can see they use these carbide inserts that can be rotated to maintain a fresh edge without me having to waste time to grind knives for a head where the finish doesn't matter, because there's a subsequent head that will cut the wood again after those heads that will provide the finished surface onto it. So with the exception of those carbide insert heads, the rest of the heads I have to do what's called setting the tick, which just means that I have to move the head in and out of the bed so that as the wood cuts in it from right to left, after it's cut by the head, it smoothly transitions to that piece of metal called our inside fence. I do this by taking a metal straight edge and rotating the head and seeing if there's a gap. Here you can see there's that gap appearing every time the head touches that straight edge, which means that the head is too far in, so I back it out and try again. And again, on this try, it should be good. There's very, very little movement in that straight edge. This genuinely is an art, not a science. Once this is done for all 6 heads, we can close the molder, we can set the key to run, and then we can fire up each individual head one by one. And then I can also turn on the feed wheels to just run automatically. And now finally, with all those steps done, you're finally ready to actually run your first setup piece. We also need to run a second board behind whatever our first board is, called a push stick or a sacrifice piece, that will just make sure that there's enough length of wood to fully push out the piece that we actually care about. Once that first test piece is through, we take out some calipers and we give it a manual measurement just to make sure everything went well, both its height and its width. Make sure it's within 5 thousandths of what the customer actually wanted. Then to give it a quick visual inspection as well to make sure there's no obvious defects. And then it's just time to run as much as they want. And that brings us to the conclusion of our video on how to run the old Powermat 700 Eagle. Thank you guys for watching. And I hope you enjoyed. Optisches Mess- und Anzeigensystem.